Who? Whoa. Okay. We are from the Xbox Linux project. Our presentation is called It's My Box, and we're going to tell you about the hardware of the Xbox, how it works, how the security of the Xbox was beaten, and how we managed to install Linux. We, that is, well, me, no, that is Franz Lehner, Andy Green, Milos Meriak, and me, Michael Steil. And I will start with the first part. Well, I'm Michael Steil. I am the project maintainer of Xbox Linux. Personally, I'm a student in Munich and 23 years old. My first part will be, well, more general about the motivation of the whole project, about our goals. Then I'll tell you what the Xbox hardware is like, what it looks like and what it works like, and how the Xbox software, the original system software that's installed on the Xbox works, so that we can see the starting points where to start Linux. What my emphasis was on is the Xbox Linux bootloader, well, one of two bootloaders, and I'll tell you about the bootloader I was working on. Afterwards, Andy will talk about hardware and mod chips, and Milos will talk about Linux kernel changes and our first steps, our first RAM disks, and so on. And Franz will tell a bit about security. In the end, it will be my turn again, and I'll tell you about the current status, what we have achieved, what we can already do, and what is left. Okay. I'll just get nearer to the microphone. Okay. Woo! Okay. So at first, who, what, where? Who are we? Well, we are all the Xbox Linux project. There are other people, other hackers around who do modifications to do other things, but our goal was to run Linux primarily. That is a port of the GNU Linux system to the Xbox gaming console manufactured by Microsoft. We have started coding or working on the project in May this year, and since then about 15 people have contributed their code so far, with a lot more people contributing in other ways. It is important to see what exactly we wanted to do, what our goals were. Let's first take a look at the goals in a technical point of view. Of course, we want to run Linux, but how? We can do many changes. We can rewrite a lot of code, but it was very important for us to do as few changes as possible, which leads to a very high compatibility with a standard Linux system, so that standard distributions like SUSE, Mandrake, Red Hat, they all could be modified in an easy way, and one day perhaps these distributions will also work right out of the box on the Xbox. So that were our goals in a technical point of view. In practice, again the same question, why? Well, this is the question also, why did we do it? What can we use an Xbox for? Since it's a computer, since it has a hard disk, I'll tell you later about it, we can use it as a desktop computer if it's a Linux computer. We can also use it as a server or in a cluster, as a node in a cluster. It might also make sense because it's a very powerful machine. The third possibility is using Linux as the operating system of the machine, to use it as an entertainment device. The Xbox is an entertainment device at the moment, and with Linux on it, it could be that are not available from Microsoft. There are many other projects out there. These projects all also hack the Xbox or do additional software for the Xbox. There are media players out there, emulators, a lot of more software. We are somewhat different to these projects because they all share the same problems. One problem is that there's a development kit by Microsoft. They sell it to game manufacturers. They use the development kit to make their games. This XDK is also available on file sharing networks, and those people use it as a plugin for Microsoft Visual Studio. And this is, of course, not okay because they don't have the license to use this software. Another issue is that Microsoft libraries are always linked statically to the executables they create. So that if some emulator or media player they distribute always contains Microsoft code the user may not have a license for. So for us it was very important that we did not have these problems. We did not want and we did not use any Microsoft tools, no Microsoft code in our code that we distribute. We used no information, no NDA information that we weren't allowed to possess. And we didn't use any Microsoft logos or trademarks and not the Microsoft green and black colors. Just to be sure. Why? Okay, why did we do it? To have a cool Linux computer. There are so many answers to the question why. Every developer certainly has their own reasons, but one primary reason is that hacking is just fun. Many people ask, or I got quite a few emails from people, hey, I hate Microsoft too, I like your project. But well, do we hate Microsoft? Is it that we hate Microsoft so that we do it? And that's a clear no. We don't do this to harm Microsoft because we hate them. We think that Microsoft harms the customers Well, what's really sure is that they actually harm the customers by not allowing them to run the software the customer might be able or might want to run, and that is Linux, for example. And we just want to compensate it with our methods to make them able to do what they want to do. Another question is, why did we use the Xbox? Why not the GameCube? And that is quite simple. The GameCube just wouldn't make such a good computer as the Xbox. The Xbox contains a hard disk. The GameCube doesn't. So what would you do with a computer without a hard disk? It can never be a standalone computer. You need some network service. The GameCube has no USB connectivity. It has no Ethernet connectivity. The Xbox has all these. Talking about hardware, what exactly is in the Xbox? So let's start with a slow PDF viewer. Yeah. Start with the hardware details. Looks quite like a PC. Celeron processor, 64 megabytes DDR, and NVIDIA VGA compatible graphics hardware. A hard disk, at least 8 gigabytes. It's sometimes 8, sometimes 10. You cannot tell without opening. Microsoft uses 8 or 10, whatever they get, but the original system software always uses only 8 to make all identical. We have a DVD drive. We have Ethernet. We have USB. And as video, of course, no VGA as a standard video output, but and even HD TV. VGA is in theory possible. The chipset would support it, and well, Linux might support it, but the Xbox system software doesn't. You've seen it's Celeron, it's NVIDIA, it's VGA. So the question is the Xbox a PC? Yes and no. 99.9% are a PC. And being a PC doesn't just mean that we have an Intel CPU and VGA compatible and whatever. It also means that the chipset is IBM PC compatible. That is, it has the original IBM PC XT80 properties. This old IBM PC already had the PIC, the timer, the PPI for the keyboard, and the CMOS. All these with the Xbox is exactly compatible with all these ancient chips that are also in today's PCs still. And it has a PCI bus, just like in a PC. It has USB, IDE, all these technologies we know from standard computers, and they are also compatible. They use the same registers as in PCs. So the question is, why did they copy all this? Why didn't they just take an Intel CPU and whatever graphics hardware and put them together in a new way, which would make everything faster and cleaner? The reason is simple. The reason is Enforce. NVIDIA did the chipset for the Xbox, and they also wanted to sell the same chipset for PCs. This chipset is called the Enforce chipset. It's available on PC motherboards, and most of this chipset is identical with the Xbox chipset. It's a North Bridge with an integrated GeForce GPU, and the South Bridge with Ethernet, Dolby Digital Sound, and IDE and everything. The only difference on the Xbox is that the GeForce is somewhat like the GeForce 4 and not the GeForce 2, and that we have on the Enforce connectivity with an AMD processor, and on the Xbox it's an Intel processor. So what does this mean for us? This has two big advantages. One advantage is porting Linux is easier because a PC, an i386 kernel, will run with quite few modifications. The other important advantage is that NVIDIA does drivers for us. On the NVIDIA's website, you can see driver downloads for Linux. That is an audio driver and an Ethernet driver. These two drivers work. Well, they are not open source. The audio driver is, the network driver is not. And the binary we get from the NVIDIA page works on the Xbox without any modification, because the chipset is really the same. But there are still some differences. Well, not actually differences, but additions. For example, there's a PIC microcontroller on the mainboard. This microcontroller contains a boot watchdog. If booting fails, it blinks the LED so that the user knows what's going on. It monitors the CPU temperature and can turn off the machine. It controls also, well, the LED and the DVD tray, the DVD eject button, and the whole shutdown process. And it's also the PIC who can detect what kind of video cable you have attached so that it can adjust the video resolution. Another IC that's on the Xbox mainboard is the serial EEPROM. The Xbox has no battery-backed CMOS. It has CMOS, but there's no battery in it. So if you unplug the Xbox, everything would be lost. Whether there's no hard disk data, the hard disk configuration that has to be stored there, but there is the Xbox serial number of for all these settings like language and so on. And very important, the hard disk key. The hard disk is locked, I'll tell you about it later, and this key must not be lost, or else the Xbox won't boot anymore. So this is stored in an EEPROM and not in battery-backed CMOS. Well, in the Xbox does not have a real VGA output. That is, the graphics hardware does not have analog VGA lines, it just has digital lines, and these digital lines get converted into analog PAL NTSC TV by the Connexent TV out controller. And one more small difference is that the USB connectors are not standard. You have quite weird connectors, but they're basically USB, and doing an adapter is extremely easy. So the hardware is very PC-like. What about the original system software? And it's very important also to know what the original system software works like in order to find out how we can boot Linux then. On a PC, there's the BIOS, the PC BIOS, and the VGA BIOS. The PC BIOS, well, that's a ROM, that's a flash chip that contains a real mode code, 16-bit code that initializes the hardware, and is also a library so that operating system loaders need not contain any hard disk access code and so on. MS-DOS used the BIOS a lot. Modern operating systems only depend on it because of the bootloader. And the VGA BIOS contains graphic support routines on a PC. On the Xbox, we have no PC BIOS and no VGA BIOS. On the Xbox, the operating system is also not stored on the hard disk, although there is a hard disk, but the kernel is stored directly in ROM. It's decompressed into RAM without accessing any hardware, any hard disk. So booting is a lot faster, and it's a bit more secure because you can't change the hard disk. It's all in these flash chips, and accessing it is a bit more difficult. Well, the Xbox kernel. What is the Xbox kernel? The Xbox has a real operating system. It's not just some library support routines for games. The Xbox kernel is basically Windows 2000. It's the Windows 2000 kernel, that is the Windows NT 5.0 kernel, which is stripped down a lot. It does not contain a user mode. All applications run in kernel mode. There are no different address spaces. There's one single address space, so we don't have real multitasking, but just multi-threading. There is no caching of hard disk or DVD data. Applications have to take care of this themselves. There's no swapping, but there is virtual memory. And also the file system it supports are very different. It does not support NTFS, but, well, UDF, that's for video DVDs, GDF, that's for game DVDs, a new file system invented by Microsoft, and, well, FATX, I'll tell you about this later. Also, the kernel does not support USB. There's no USB logic in the kernel. All games have to add their USB code themselves in their libraries. And one main property is also that the kernel is static. It's one 500 kilobytes program. Everything is in one, and it's quite compact. But it's still very compatible with Windows 2000, with the Windows 2000 kernel. In order to understand what the boot process looks like, we have to look at the hard disk. I told you that the hard disk is locked by an ATA password. That's a standard mechanism defined in the ATA standard. If you don't unlock the hard disk, you can't just put it into a PC and read it out. It has to be unlocked. So this is a bit of security, but difficult to read the contents of the hard disk. The hard disk of the Xbox is always treated as an 8 gigabytes one. It always has 5 partitions on it. And the partitioning is implicit. That is, there's no partition table anywhere, but the kernel has the partition data hard-coded into it. So we cannot play with this. This is the partitioning. There are 3 partitions at the beginning with 750 megabytes each. Games can store the temporary data there. There is a system partition of 500 megabytes. We'll see what this has to mean later. And the data partition, which is the rest. Save games are stored on the data partition, as well as ripped music. You can insert audio CDs and they get ripped by the Xbox in Windows Media format on the hard disk. You can use the space for that. All these partitions are in the FATX file system. You probably already see that FATX has to do with the FAT file system. So FATX really is a derivative of FAT16 or FAT32, but with some minor cleanups. That is the file allocation table structure is just the same as on the old disks it was done for. Well, FAT was developed for disks like these of 200 kilobytes, and it still works a bit with larger hard drives. And FATX shares many of these properties. But the cleanups are, for example, that there's no 8.3 limitation, and there are no workarounds of this problem. They have done some additional code to make it a bit more modern, but it still has the old problems like cross-linked files and everything. It is not really secure. Adding support for FATX to the Linux operating system was therefore not so difficult, because we could use the original sources for FAT and just add some code. Okay, so what does booting look like now? The kernel starts up. The kernel initializes. That just takes about 1/10 of a second, and then you see the boot up animation. And in this time, the drives, that is the hard drive, and the DVD drive spin up. After the animation is done, the kernel checks if there's a DVD in the drive and loads a file named default.xbe and executes it. If there's no DVD in there, it starts an application from hard disk. It's always called xbox-.xbe. That's the Microsoft dashboard, and you see it on this picture. It's a menu that allows you to manage your save games, listen to music, or manage your music collection, and do some settings like time zone and so on. All these applications are XBE files. XBE stands for Xbox Executable. There are 2 main differences compared to the ELF or the Windows exe format. One is that they are always digitally signed, or they have to be digitally signed, and the signature has to be correct. If the signature is not correct, the Xbox kernel won't start the XBE. And if you change a single bit anywhere, it won't start it. So this is the main copy protection idea behind the Xbox. And the other difference is that there are no DLLs anywhere. There is no code that gets loaded afterwards. All code must be in XBEs, and one XBE can chain load another XBE, but there are no libraries, and this is also because of security. So where can we start booting Linux now? There are 2 possibilities. One possibility is, why not just write an application that looks like a game, like And this executable is supposed to load the Linux kernel and start it. Our problem with this solution is that we cannot digitally sign this XBE file, so it will never work in a standard Xbox. In order to be able to run it on a standard Xbox, well, not on a standard Xbox, but in order to run it on the Xbox, we have to patch the kernel. So we have to open the Xbox and change the contents of ROM. This has been done, and Andy will talk about this later, but not without modification. This solution, well, this is the first of two solutions. The advantages, or well, it makes sense for people who want to use the Xbox as a gaming device still, and boot Linux when they want to use something that has to do with Linux, because games still work, the Xbox kernel is still there, and Linux is there on demand. The other possibility is for people who want to use the Xbox only as a server or as a desktop computer with Linux. They cannot run games anymore because this solution replaces the ROM image with an application with the ROM contents written entirely from scratch by ourselves. It does not contain any Microsoft code. It takes on the machine, it takes over the machine from the beginning, initializes the hardware, and boots the Linux kernel. So that you can't see the difference, you can't see a real difference between a PC and the Xbox anymore, because they both just can run Linux, and you don't see the Xbox as a gaming device anymore. The problem also with this one is that if we want to change the ROM, of course we have to replace the ROM chip on the board, and also in this solution we have to modify the Xbox. We have to add additional mod chip hardware. Since I have been involved with the XBE bootloader a lot, that is with the bootloader that is an XBE file and runs the Linux operating system, I'll tell you about this one a little. Since it's an XBE file, it gets loaded by the kernel and runs inside the Xbox kernel environment. That is, inside the Windows NT environment. It can call the Xbox kernel. The calls are about the same as the Windows 2000 native API calls. With these calls, it loads its own configuration file. It loads the Linux kernel, the initial RAM disk. They all must be loaded into contiguous memory because we're in a paged environment. We have virtual memory, and then if we turn paging off, the kernel must still be there in memory, in a contiguous area of memory, as well as the RAM disk. And after turning off paging, we can just jump into Linux, into the protected mode entry point of Linux, and start it. Well, it's not actually this easy, especially turning off paging on an IA32 processor is a real task. It's really tricky. But we can say that the XBE bootloader really works well already. So if we have a bootloader, we want to use we need a boot menu, because if we put the bootloader only on a CD, we would have to insert the CD every time we want to boot Linux, but we want to install it in the hard disk. So what do? We need a boot menu for the hard disk, and for this we can abuse the dashboard, and we've done this. The dashboard looks like this on the left, and we've added this menu item boot Linux with a B key on the picture on the right. The dashboard is this xbox-.xbe file on the hard disk that gets started every time there is no DVD in the drive. The dashboard menu itself is written in JScript, while the XBE is just a JScript interpreter. you can calculate some more digits of pi, but you cannot load another XPE. There's no library call for starting another XPE, and we would need this in order to run the Linux bootloader. But there's an Easter egg in the dashboard. If you insert a CD and say, Xbox, please rip this CD to hard disk, the Xbox will ask you, what do you want to call this CD album? And if you enter Xbox, it will start another XPE file. The name is hard-coded into the dashboard, and this XPE file shows the credits of the Xbox. It shows all the creators' names of the Xbox system software. And we can use this. We changed the JScript. The JScript looks about like this. If we want to boot Linux, the music collection dot add soundtrack with exactly this, and if we exchange the XP file, we have our Linux boot menu. Okay, this was my part so far. I think Andy will. Questions, please, at the very end, because each of us tells very different aspects of it, and I'm sure that others might talk about aspects you might now already want to ask questions. Okay?
Okay, my name's Andy Green. I'm English. In a moment you'll see my introductory slides, but while that's happening, do not look behind the curtain. I can promise you a giant cat and a giant potato during my presentation, so keep your eyes open. Oh, louder. Okay. I was also going to say that I am the most bald member of the Xbox Linux team. I was going to say that I'm the most bald person here, but I see that's no longer true. So here we come. What processor is in that thing, Milosh? Ah, Celeron 300, okay. Okay, we're nearly there. Wait for it. Okay, this is OpenOffice. I found it to be very useful. Okay, so this is my bald head being illustrated here. Is that a click? Okay, so what I do, apart from stupid jokes, is hardware and firmware, and I'm kind of the main hardware person in the team. I run Red Hat for about a year. I know that's just not cool, but I'm being honest, all right? And prior to that, Wintel for about 15 years, so I know how stuff works, maybe not in the right way. That was a double click. That one's for free. Yeah, I'm no kernel hacker, that's what that was saying. Yeah, so I do hardware. By the way, there's 100 slides in this presentation and 35 minutes. So we'll be doing approximately 180 slides per hour. So fasten your seatbelts. Yeah, I work as a consultant. I'm sorry. I don't play games on my boxes because there's just no time. Because I'm married with 4 kids. And I've got 2 cats. But this is the giant cat. She's called Wiggly Wog the Mog. Okay, so I'm going to take you through a bit more of a story about how things happened over time. But first I'd like here. I can smell you. So, hire some more security people. That's actually a really cheap gag. I'm ashamed of you for laughing at that cheap gag. They did a good job. They actually did a good job. And it's true, I couldn't have done any better. It would have been worse, in fact, probably. And their main job was to get the box working and playing good games, and really, they did a good job. So, I'm sorry, Microsoft. Okay, so now we're going to cover what the situation was before our project really got started. I don't know if you've seen this, but this is Steve Ballmer as a evil pumpkin. Some guys did this at Halloween. Really, Microsoft want to own your living room. That's why they made the Xbox. They want to be Disney, and it's a big coin slot that leads back to Seattle. They want your money. If they can't get your soul, they'll have your money. It's sold at a loss. Nobody really knows except Microsoft, but it's around $100 a box. And really, they need you to buy their stupid games. If you don't buy it, then it's money out of their pocket. And really, they want children to do their selling for them. They want their kids to go, please, Daddy, please, let me have this stupid game. And then they can get your money. And they don't want anything else from you or your children, just your money. Okay, so I'm going to skip over some of this stuff pretty quickly because we've got a lot of slides, and Michael already did a good job of giving you some idea of what goes on. It's really bad, this Xbox. It's a PC, and it only runs Microsoft code. Where were the antitrust people when this was going on? It's totally outrageous. We fixed it. It's no charge. It's 700. Thank you. It's 733 meg Celeron. It's pretty reasonable. Can do most stuff. It's a nice video card, and it's a bit tight on memory. It's PCI, just like a PC. No ISA, obviously. It's 4 front panel sockets, which are standard USB 1.1, but in a funny format. There's the IDE, which is a hard drive and DVD are both IDE. Normal Ethernet. There's strange AV outs, which we'll be looking at in a rather too few minutes. It's I2C inside 4 chips in to communicate on that, and that was very interesting for us in cracking it. 2 buttons on the front. Their intention is that the thing is completely hermetically sealed. So they put hard crypto signatures not only on the XPEs that Michael mentioned, but also on the BIOS itself. Only a properly RC4 signed BIOS will start up, otherwise the thing will just crap out. The BIOS is only willing to run executables signed with a righteous RSA encrypted hash, and this is a serious hash, as France will be talking about. It's yeah, not the whole of France. I mean France, actually. I'm sorry. They probably are talking about it. It's a 2048-bit RSA encrypted hash to authenticate the fact that the software has been blessed by Microsoft. Interestingly and critically, the XPE header contains bits to say what kind of media the XPE may be delivered by, and that attribute is also part of the stuff that's hashed and then encrypted. Well, the hash is encrypted, so there's no way you can take a game off pressed DVD and stick it on CDRW, because it will say, wrong media. hard drive is locked. Okay, you're going to be seeing this somewhat truncated slide several times from different angles. I'm not going to bore you with it too much, but this is the entire chain of trust. It starts at a 512-byte ROM, which is held in a chip called MCPX, and the ROM then looks at the encrypted bootloader in the 1.0 box, attempts to decrypt it, and then look for a signature. If it finds the signature, it then runs the copy of the encrypted bootloader in RAM, and that then loads an encrypted kernel into RAM, and if everything's happy with that, then it will get in some XPEs from one source or another. They are the only three ways to get it in. Sneakily hiding over there is an evil object we'll be coming back to. Something else you need to know is that the top of the flash image, they place something that we're calling X codes, which are 9-byte initialization table. These are interpreted by a small interpreter inside the ROM and are used for bringing up the hardware that's necessary. They seem to have done it as a interpreter for compaction reasons. If they did it as just linear code doing all the config, it would have took up a lot more space. So each of these X code guys is 9 bytes long. There's an opcode and 2 D-word arguments. It happens from the ROM, and the ROM is the first guy who gets control. So this is happening very early, before anything else. There's no hashing, encryption, other funny business with the Xcode table. It's about 3K long. There's things like IR instructions and memory read-write and PCI config. Okay, you might have heard of Bunny's hack. Bunny is a guy who I don't talk about until the next slide, who basically looked at this 8-bit differential bus which runs between the MCPX and the CPU. He's a guy who was a MIT student at the time, and he made this interesting little PCB which he's glued with epoxy onto the motherboard to tap that bus. It runs at, I think, 200 meg joule pumped, I think. And he basically has captured all that stuff. Oh, by the way, he told me it wasn't the Xilinx demo board. That's actually something else that he designed. That's an error in the slides. So he captured it, and then, because it was data only and had no address information, it took a bit of mixing and matching to get it all lined up. But eventually, he saw the contents of the 512-byte ROM in the MCPX flying across to the CPU and reconstructed it. So this was also revealed an RC4 key, which is a short key for the RC4 munging up algorithm. And this caused a big problem because the encrypted bootloader was encrypted with that RC4 key. Now this had been exposed, anyone could decrypt and re-encrypt the bootloader. And of course, once the chain of trust is broken at any point, everything south of that is broken. So this caused what we can call a crisis at Microsoft. It was a really powerful hack to suck data off that bus. I don't think anyone expected it. They had basically done a security by obscurity job, and their obscurity disappeared, and now modified BIOSes could be made, which just didn't care what Microsoft wanted. And hacked BIOSes with that attitude turned up in May. They basically no-op out all the checks involved in assessing whether money has changed hands for an XBE. And CDRs, just ISOs of CDRs spewed on Usenet. I'm sure that caused router problems that day. So how do we deliver these changed BIOSes? Initially, via this rat's nest of doom, which is basically 30-odd wires going to test pads for the flash buses. So the address and data buses for the onboard flash were taken and given to another flash chip. but it worked. So at this point I got interested and designed this beast called Milksop. It's a pun on the TSOP name, which basically clips over the TSOP format flash on the motherboard and overrides the bus signals. It has very low impedance drivers and just basically craps all over whatever was going on from the normal driver and reprograms the flash. It's available off my website as a GPL project, one of several we'll be looking at, and some people have built them. So that's a clip that you can clip over. It works pretty good. You can completely give Xbox a brain transplant in 45 seconds, but the clips are crap. That's the sad news. Anyway, this ended up, Microsoft blamed NVIDIA, who is obviously their fault, obviously NVIDIA to blame for that, and they threw away all of their MCPX chips they had stocked up with the RC4 key and ROM. They just binned them, said, okay, we're not going to make any more, you've got to pay NVIDIA. So they couldn't do much about this because they wanted to stay in bed with Microsoft, and they said, okay, look, we know that one didn't work out well, we'll cook you up a new one, but this one's really, really good, we promise you. And this only turned up when NVIDIA were doing a financial call, and they said, where's all this money gone? And the guy said, bleeding Microsoft, don't get me started, So they're in arbitration now about money, so that's sad. So this is moving on now to how we got our snout into the Xbox. There's a thing called an LPC bus on the box motherboard. It's a low pin count bus. It's a standard bus. It's an Intel 3 standard. It's a 4-bit bus, runs at 33 meg, 32-bit address space. It's kind of like a mix between PCI and ISA over serial. It's about 1 microsecond a bus transaction because of a 4-bit business. It's pretty good. There's a trick that was already known by other people, which is if you can force bit 0 of the original TSOP data bus to ground, then the thing will try to boot off the LPC bus. This obviously adds some good thoughts for us. So it occurred to me that we need a new kind of tool which will help us write code on LPC and get it tested out. So I designed another thing called Filtraw, which is short for infiltrator, because that's rather what it did. Basically it hooks up a PC to LPC. It's got 1 megabyte of fast SRAM, which is dual ported all the time. It's not modal between the PC or the Xbox. It's permanently available to both. The LPC bus has wait states as part of its function, so this is used to mediate access. And also, using this dual port, you can send data back and forth between the PC and the Xbox. The first problem that we had is there is no good I/O that we could take over quickly with small amount of code and use for getting stuff in and out of the box. So we made 3, 2 went to other project members. I wrote a Telnet type app which used the I/O thing. And the idea of all this was to write a clean BIOS with Linux in it. Now, xboxhacker.net was a really very valuable website for all of us. It's basically where we met. Lots of people were involved in looking at the inside of the Xbox, not just us, and some of the people had different reasons for doing it. And Visor was one of these guys. Just want to talk about motivation of hacking. I think honor is what it is actually about. I don't know whether you noticed, but most of the hackers are male and relatively young, and because there's no King Arthur around at the minute, we have to beat our dragons on our keyboards. Also, some geeks, I don't think really wage slave to a greedy, pointy-headed boss. But of course, many geeks are quite happy with that anyway. But GPL and Linux for me is something that I can really work for without feeling bad about it. And I'm pleased to undermine exploitative monoculture. And you can learn stuff. Okay, here's what you need to know. This is the memory map of the linear memory. This is the true address bus type memory. You can see at the bottom there's 16 megabyte slot set aside for flash. In fact, it's a 1 megabyte flash fitted, and they don't decode the upper address line, so you just get 16 lots of it. At the very top, there's the 512 byte ROM, which is hidden, allegedly. So you can see x86 will start up in the ROM space, very high, and it takes great steps, as we will see in detail, interesting detail, to map itself out of memory before the thread of execution leaves the ROM space. So this is Visor's hack. A giant visor there. He was a smart guy. He's not very active at the minute. I used the past tense. Who knew quite a lot about the box and had been quite active when we got started in already looking at it. So we learnt quite a bit from his work. He could be a little cryptic. So the undeserving, i.e. people who couldn't work out his cryptographic methods, wouldn't be able to use his stuff. So, the guy at Microsoft who wrote the ROM, this is 512 bytes, remember, a lot of room to make mistakes in. He tried to be too smart while not looking at the big picture. The problem that he was looking at was exiting the 512 byte ROM while not leaving it paged in, hence the picture. So, the pseudocode that he wrote was I'm going to decrypt the flash. Okay, I'm going to do my business. Then I'm going to look at the signature. Oh, if it's a bad flash, oh, I'm going to go to hide us here, which is at the very end, not only of the 512 byte ROM, but of the whole address space. So he carefully put an out instruction right at the end. Okay, wiser heads among you are going, ooh, don't like the look of this. And he said to himself, they'll never see me now. But if he had seen my fantastic diagram, he would have realized that what happens after he falls off the end of the world of his ROM, oh yeah, it's like Albrecht in Das Rheingold, but I don't have time to go into that. Execution is going to roll over to 0, and no exception is generated by the CPU, which might surprise you because there's a lot of other things that will generate an exception. Xcodes can be used prior to this to force a jump far up at 0 in the RAM. Yes, it's true, they did. Okay, so now we have a famous Michael Style hack here, which is the second major hack that occurred involving the MCPX ROM. He had a look in the ROM contents after we got a hold of it, which I'll cover out of sequence, unfortunately, and saw in there that final out instruction, which paged out the ROM, was a PCI config write. So he had the idea, okay, Xcode can do PCI config writes. I'll feed the Xcode to do the page ROM out config write and see what happens. Nothing happened, because in the MCPX ROM interpreter for Xcodes, they check for that exact PCI config address and reject it. So score 1 to Microsoft for that. crappy address decoding for this peripheral block. They did not look at the function part of the PCI config address. So in fact there are 16 addresses which will perform the same action. Did their code look for this? No. So the end result was when Michael tried it, the ROM got paged out. CPU caches weren't up at this point because this was during the Xcode interpretation very early. Execution dropped through to flash at the same address, but we had prepped the flash with our own code. Yes, game over. Another severe crack. So, how did we get hold of this secret MCPX ROM? It's something that we really wanted. Yes, get on with it. We could use the visor hack to let us get out of the ROM. And although the ROM had been swapped out already by the visor hack, it occurred very late in the process. So we were able to capture 300 bytes of it from the CPU caches, which must have depressed the people who wrote it. So we dumped out what we had to I2C and captured it. This was version 1 of the I2C capture unit. It's a design I was working on for another company. It's used Xilinx FPGAs. So I wrote a little bit of code to copy it all into SRAM and read it back on a printer port. But version 2 of the I2C snooper was a piece of wire. Milosh wrote some really nice code to kill off interrupts, and I wrote a Linux app which just sits in a tight loop parsing I2C traffic, and because there's no interrupts, no nothing, it can do 100% capture. It's only 100 kilohertz, the I2C stuff. So that's pretty cool. So once we had that, we had the RC4 key ourselves. We just heard talk of other people having it up to then, and we were able to decrypt the second bootloader, which was done by Oswald B. And he'd already prepared an RC4 app to do this job. When he put our key in, code popped out, a bit more work from Paul, and the kernel popped out. And we had disassemblies, which was very interesting. So this again is just to underscore that once we had the RC4 key from the MCPX ROM, which was like the ultimate root of all trust, the thing just fell apart like a cheap suit. This is just a little aside on team formation in GPL projects. Team formed itself. Xboxhacker.net had made the project and the progress visible, and because it was quite interesting as this new stuff was discovered, a lot of people were reading it and were motivated to try to help. When they saw that particular moment had come with stuff that they knew how to help with, they jump in, and they're contributing for joy and just love of the work, not for money. It's very different from a commercial project. And after their moment and their knowledge has been contributed, they fade back out, but what they've done remains. It's the basis that other people will be building on, and they can feel good about that. So, Evil Pick Challenge. I wanted to write a fresh BIOS so I could just pretend the thing was some kind of embedded machine. I got on with that with the knowledge that we had, but the thing kept resetting 200 milliseconds after it got started. I captured the I2C traffic and saw some stuff, which is 4 bytes coming out of the PIC and 2 bytes being sent back to it. And if they weren't the right 2 bytes, then you got reset. It's in fact some kind of crypto authentication. It's pretty sneaky. It's XORs and adds, you just never guess it in a trillion years. It's totally pointless because we busted their chain of trust, so nothing could hide from us. Surfer Dude said, oh, they're and we were away. So it was like a completely pointless mechanism inside the box. So with that, we were able to make a minimal clean ROM which would boot and stay up with no Microsoft code in it whatsoever. It also didn't init any of the interesting peripherals, but it was like the first sign that we could take over and put our own stuff on in like a stable platform. So the focus moved to enhancing this to have Linux, which is the next part. So I'm going to whip through this really quick. I'm sorry because it's we're pushed. Surferdude enhanced the skeletal stuff to work with GCC, which was no libc because there wasn't room. We only had 1 megabyte in total, but it was absolutely wonderful to be able to code stuff up in C rather than ASM. Everyone basically started looking at the peripheral init code that was part of the Microsoft stuff and recoded it. And Michael and Milosh put together VM liners and initrd suitable for this miniature environment. I tell you, I'm compressing weeks of sweat and work here in one slide. I think Milosh, you're talking a bit more, yeah, okay, because it's quite interesting how they did that. But we ran it up and it just keeled over dead, and there was no I/O in the machine that we could toggle to tell us what was going on. So Milosh wrote a Linux console driver to work with the Filtraw I/O that I described earlier. And with the Telnet type app, we ended up with a kind of remote console that was connected directly into the flash address buses. And with this, we were able to see the early Linux boot messages, and that made us very happy. We found out that it was crashing while it was walking the PCI kind of buses to find out what bridges were where. And it was some kind of bus error provoked by a problem in the MCPX logic. So fixed that, got all the way to a BusyBox console, ls the init. I mean, typing ls and seeing some stuff come up doesn't sound like much, but it was pretty cool at the time. And Milosh took over. He got Telnet web server and other things set up. And finally, we had like a headless thing because we weren't properly initting the I/O, but it was a fully functional Linux server. The Ethernet was up. And we prepped the distribution web server with our message. So when you connected to your Xbox, you saw this stuff instead of the Microsoft logo. I won't bother repeating it to you, but basically it's saying, so with this, our dreams come true, and we make Slashdot. Slashdot readers are very happy. Xbox is definitely not worth the hours all developers working on it are just for to boot even a working distribution. Why is this a good thing? Because you still have to buy an Xbox and give Microsoft money. Oh, that was too... there we go. Linux on an Xbox. The question begs to be asked, why? Thank you, Slashdot. Michael Steil was really interested in the XPE format before this in terms of another way in, and he'd made a clean skeletal app with .db, no Microsoft code, to give the XPE header format. So it was unsigned, strangely enough. He was able to use this to find another way into Linux. Once we'd come up via Filtraw, we fixed and patched things like PCI bugs, some other things in the Linux kernel, which would have killed it dead. We had some faith that it would work. We come up via an XPE after that. And this time, because we come up via the MS BIOS, the video was up. So after a bit more work, Milosh and Michael got the frame buffer up in Linux. So we tried the USB driver, NVIDIA drivers, the Ethernet driver, they're all working. It's starting to look pretty good. It's in fact a distro. based one. And both went out on SourceForge, and we make Slashdot again. Good grief, idiot. Get a life. Buy a $299 Walmart PC and load your Linux crap on it. Shut up, Dick for brains. You don't even know what he's talking about, so you don't know what you're talking about. I have an Xbox and no games, just a DVD kit. I entered the Taco Bell challenge 600 times. I hope your ass exploded from all those burritos. Thank you, Slashdot. Michael and Milosh's work continued, and they made a fantastic Mandrake 9 ISO, which I eventually got to use because I can't write any CDRs that my Xbox will accept. So Milosh actually sent me a set after it had been done, and I was really, really pleased with that. It's very good. It's got KDE3, OpenOffice, and even Tux Racer, currently 1 frames per second. So we put it out on SourceForge, 53,000 downloads so far. It's 350 megs, so I don't think they were just kicking the tires. And they make Slashdot again. Even if it's nice and fun that they have made it possible, why? Why would I want to run Linux on an Xbox? I don't know. I'm sorry. Much wiser if they port Linux to all these different PDA devices. That's a hot market, right? We're sorry. Slashdot. I beg your forgiveness. Running Linux on the Xbox helps no one except Microsoft, you fools. Wowee. Now I can use wine on my Xbox.
If you use wine on a girl, you can use her Xbox.
Okay, dating tips from Slashdot here. Thank you. Right, finally to Cromwell. Despite this fantastic success, the XPE loader method still required the normal MS BIOS, and the normal MS BIOS wouldn't run our XPE because it smelt that it was not evil. So it means that you have to run hacked Microsoft BIOS code to run Linux. It's obviously not a good state of affairs. So we continued work on a clean BIOS, completely clean. We removed Linux, and for ease of putting onto mod chips, many of which are only 256K, that was our aim, to fit it into that. When we made this decision, we had to go back to the horrible state of affairs from the first clean ROM, which was we didn't have no video up. And so, nor was the hard drive unlocked for us by the original BIOS. Michael's already covered this really well, so I'm going to whip through it. They basically didn't want users to be able to swap hard drives because, you know, that would be good. So they store a unique serial number in the EEPROM. Ooh. And they basically lock the drive up tight until it gets a secret password sent to it. And this is a horrible drawing of how that works, but I know France is going to cover this in more detail. Basically, they take in a few ingredients from the box state, like the serial number, and encrypt it, hash it and encrypt it with RC4 key, which again is completely pointless in this case because we broke the chain of trust early and have the RC4 key. So those are the ingredients. Speed bump reversed the algorithm, but we weren't sure what to do because this was the first time that we had a Microsoft key that we wanted to redistribute. It's actually a interesting question. I mean, what is that key? It's a bunch of numbers. It is a bunch of random numbers. Can Microsoft say that we are bad people if we send out 16 bytes of their random numbers? I mean, is it truly evil to do that? presentation. And we look at the judge's face in our imagination when we start talking about 16 bytes. Microsoft are saying it's our copyright, and we were a bit worried about that judge's face, basically. So Franz Lehner had a great idea, which he's going to cover in slightly more detail than this shortly. He had a good old look at RC4 and this SHA-1 hashing algorithm which they were using, and he found that the key, the first thing that happened in these algorithms is the key was munged to a constant. So we just shipped a constant, and you can't get the key out of the constant. So this is Franz's idea. So there was no way I would have thought of that, because I looked at the algorithm and just gave up, whereas Franz sussed it out. And he called this the Friday the 13th attack, because that was the day that it happened. Steve Ballmer's not so happy now. Okay, the bringing the video up from scratch was pretty tough, because the NVIDIA register set is just crazy. There's registers all over the place in memory mapped space, covering something like 16 megabytes of register space, and they're all over the place. It's pretty crazy. It took 4 months to get video up. Part of the reason, I think, was that there wasn't much effort towards it, because the XBE booting method already had video up. We already had this great Mandrake distro out there, and I think a lot of people were just happy with that. But not me, because I'm a stubborn bastard. We finally solved this with the Franken video hack, which was 2 Xboxes on a network, and I wrote an app to basically dump all of the video registers out of one and push them into the other. And we found fairly quickly the minimal set of registers, and we were able to, or I was able, because that was just me, I was able to boot into Linux from Lilo via 16-bit BIOS, which Michael had done. But Lilo wrote some stuff to the disk which made it no longer function as a native Xbox. So we kind of gave up on that pretty quick. And another problem was that Box, which is a pure 16-bit BIOS, a good BIOS, but it still comes up as it intended into 16-bit. And the problem was the Linux kernel cannot take the frame buffer init parameters from 16-bit. The only way to tell it about where the frame buffer is, how many lines, and so on, is from the 32-bit entry. So disaster there, we had to throw that away. Instead, we put grub RiserFS code into Cromwell, kind of brain transplant, and now it reads itself. It parses RiserFS natively and picks the kernel and any init.rd directly off the disk, and it doesn't write anything to the disk for this function. We also put UDF capability into the BIOS as well, and this allowed it to install Linux itself off the DVD drive, again without any Microsoft code. So you can install and subsequently boot into Linux without any Microsoft code getting in there at all, except the 512-byte ROM, which we can't do much about. Okay, now another interesting story, the 1.1 box. In October, a new kind of box started to come, in Australia first. No hacked BIOS from before would work anymore. We called it V1.1, and this was Microsoft's response to Bunny's LDT tapping hack from February. There were some small USB daughter card got merged onto the motherboard. Basically, some things they should have done in the first place. Because we heard about this from the financial call with NVIDIA, we had some advance warning, and a guy called Asterisk came up with a pretty good hack. So I implemented this on a 1.0 box while we were waiting for the availability of the 1.1, and we've agreed to keep the method secret. The box from Australia was delayed, and I managed to get one in England before it arrived. Got it on Tuesday. I had the MCPX ROM out the same day. We have Asterisk to thank for that, from his methods. Xcodes were the same, which was good news. LPC bus was still there, still working. They'd fixed the missed trick. This is the paging out the ROM early method. They'd made the whole ROM area bus error if you touch it after the page out, so there was no way to get control after paging it out. And this is the interesting thing, I think you'll all be interested in this. This is the first working Palladium type stuff that we've seen, and we understand it pretty well, and I'm going to describe it now. No more encrypting the BIOS with an RC4 key. Bunny had shown there was a problem with that. The bootloader, the second bootloader section of the flash, is hashed by the ROM now. So when Microsoft actually decided what to go into the ROM, they had their second bootloader, hashed it using a hashing algorithm, and stored the result in the ROM, in ROM. So they've effectively locked the second bootloader code. Their plan was no edits can be made to this. It doesn't matter that it's in Flash and the Flash can be perverted. It's not interesting because the ROM gets execution control from the start. It computes the hash of the second bootloader. If it's not happy with it, it doesn't execute it. And it's got in ROM the correct hash value. And it's important to note, they have made Flash ROM by this in terms of execution capability. They've removed the ability to edit what is in the Flash. Okay, so here's the changed chain of trust. Instead of an RC4 key decrypting the encrypted bootloader, we now have a hash which checks the authenticity of the bootloader before jumping straight into it. Yeah, that's it's no longer that box there is in fact dead. It's no longer copied into RAM as part of the action. It's executed in situ. That box is actually wrong. Okay, so we had the MCPX ROM from this guy, and we had a look at the hash algorithm. Somebody, I'm afraid I've forgotten who, it wasn't me, that's for sure, matched the algorithm to a known guy called Tiny Encryption Algorithm. And there's a URL there for the homepage for it. Franz Lehner, again, started asking around on Sci.Crypt about T. I was pretty depressed at this point because it was a very good scheme of Microsoft. So on Friday afternoon, this is still within 1 week, Franz reported that a guy on Sci.Crypt was describing a weakness in T. And here is our email. Franz says, Andy, take a seat. Scott wrote back. Blah, 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 blah. I'll cover this in more detail in a moment. WTF, 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 that's me. This cannot be true. Blah, 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 blah. So I sprang into action with this piece of news. I got drunk and said I'd look at it over the weekend. Yes. Okay, the Sci.Crypt guy had replied that T, when it will produce the same hash results for different input. Yeah, wait for it, it gets better, it gets better. On any 64-bit block, it delivers the same hash if bit 31 and bit 63 are flipped together. What the fuck kind of super hash is that? I mean, what? So Saturday morning came. In fact, I turned into a red-headed woman. It was that bad. So I sat down to read Xbox Hacker, and Executor, a mod chip manufacturer, had suddenly announced overnight that they'd cracked 1.1. So I read all the posts on Xbox Hacker. A guy called Troad, who's a Scandinavian hacker, had seen the traffic on Psy.crypt and posted it to Xbox Hacker. The Executor mod chip people had seen it, and while I drank some coffee and read Slashdot to see more bad news and dating tips, a poster called MViz suggested that I look at the first Q word in the hashed region. So the first Q word of the hashed region of the BIOS was a relative jump, and normally it goes off to FFFCD588, and there's some junk padding zeros after it. You can see what's coming here. So I flip bit 31 and bit 63 as according to Psy.crypt, and it gives us a jump to 7FD588, which is a pretty funny number. So, oh, they're way ahead of me. I see I'm talking to some real hackers here. So, after passing the hash test, it jumps normally to the start of the hash region, which is where this jump bar is. It passes the test. T can't tell the difference. Now it jumps about 8 meg up in RAM. And, well, normally it would crash. But we can use the Xcode interpreter to push another jump earlier in the RAM. And that puts us back just where we want to be, running from Flash, our own code, everything forgotten, no problems with hashes. Game over, man! So, here is the giant baked potato that I promised you. I took my wife out for a baked potato. I had done so well, in fact it wasn't all meat, but... And we even had cheese. Oh yes. So, this Microsoft multi-million-dollar effort, because they threw away all those version 1.0 MCPX chips and charged NVIDIA for it, was defeated by flipping 2 bits. And it got even more bizarre. Visor was in contact indirectly, wondering what had happened to his hack. I tried it, and it was still working. So, it was a weird situation. We had this elaborate public hack, which went through cryptanalysis of hash methodologies and blindness of hashes, all the rest of it, and a simple private hack, which we now knew still worked. And it was highly likely, I thought at least, that that guy was going to stay there, because whoever did the work of lining up his out instruction to all the Fs, he was really happy with that. He thought that he'd done a really good job and no one could see his ROM. So Executor agreed to keep this stum. However, silence lasted until mid-December, and then Executor accused a rival BIOS, hacked BIOS group, none of these are clean, called EvoX, of using this forbidden hack, and they did it on their front page of their website. But it was a misunderstanding, because EvoX had used already known hacks, and Executor ended up apologizing. But on They knew that we and Executor were withholding a hack, so it'd be there for their version 1.2, because we really did expect this to be the case. But the thread kept growing. So I waded in and took slightly the wrong tone. Shut the fuck up, I think was the general tone. Made people unhappy, but they stopped talking about it, because it seemed to, some of them at least, realised that we were trying to do this for good reasons. But Envies, the guy who helped with the T-hack, posted all about the Visor hack on Xbox Hacker, and we know that Microsoft hired a guy to monitor Xbox Hacker and the other activity. So this was a very bad situation. So that was my face at the time. I was ranting and raving, and anyway, the outcome of the whole thing was that Visor was busted. So next time we're down to 0. We're going to be starting again. It's an open question whether we should keep more things public or more things private. Xbox Hacker, fantastically useful website. We wouldn't be where we are without random people being able to see progress and decide whether to join in. And yet, if we find something really sweet, naturally we want to keep it quiet. So it's hard to know what to do. And like it says, we're far more powerful working in the open. Okay, some quick, how am I doing for time? All right, okay, some conclusions. We basically did it. We got Linux up, like we said. It was a fantastic learning experience for everyone. The major problems were crap that came from Microsoft. Once we got through that, we were all right. It's just a PC. It's a PC. We shouldn't be surprised it's running Linux, actually. It's a PC. The hidden ROM was something they put in to kill us. The tests, signature order hashing on the flash, something they put in to kill us. The PIC challenge, something they put in to kill us. And the hard drive lock crypto, something they put in to kill us. And the XBE crypto, something to put in to kill everyone. The antitrust people really should look at this. Microsoft have made a Microsoft-only PC. You know, hello. So, some lessons. Strong crypto worked really well. We'll see more of it next time. Hopefully not T. Microsoft have a job to avoid implementation problems. It's really hard for them to get it perfect and in ROM. The RSA encrypted hashes will defeat any direct attack, and this is Palladium. It's going to work. Palladium's going to work. They can't fix implementation problems, maybe, so you can come at it indirectly, but the direct frontal attack on 248-bit RSA, don't even bother. But if you've got a machine in front of you, then you can always take control of it somehow. Microsoft don't care. They care about mod complexity and being able to mass produce and distribute it. So there's two kinds of attack. A secret attack, like we were mounting, where forbidden data is collected for analysis, like the MCPX ROM, and consumer attacks, which can be reproduced and distributed. And of course, Microsoft see all consumer attacks by definition, because they're made publicly available. Secret attacks are kept secret by us and can be far more extreme. They can be gross violations of the sanctity of the Xbox. We just need to get lucky once with a secret hack. Microsoft have to be lucky all the time. And the trend to using RSA, asymmetric encryption, they intend to make it less useful to find out any secrets inside the box. Because even if you know, because of the RSA, you can't change. Just we're almost at the end now. A little note about hacker compatible. like Envis. Envis wanted to post about the Visor hack. In truth, he had every right to. He saw what went on earlier. Okay, but there was a bigger issue which he decided not to deal with. The hackers that we came in contact with tended to be more focused on individual results. They wanted to issue, as it says, whip the finished thing out of their ass and say, here you go, I did that. And public mastery of the issues by the individual were very honourable. They're like what they were after. The hackers generally had near-term technical goals. They wanted to get some cool thing working, whereas we had longer term. We want the Linux to be up on all the Xboxes, not just today, but future versions too. And it's a mismatch. But recognition of individual efforts is crucial to both cultures. In truth, I say this like they're two different animals, but there's a lot of crossover. It's just these are things that I noticed. Okay, IP company versus GPL. You are a consumer. We just want your money. We have a duty to maximize shareholder value, and that means locking you in and screwing you. And we check up on your lying scumbag ass. Whereas with the GPL, every user is potentially a contributor. You're in control, but not over other people. There's no money, but all contributions, i.e. improvements to code, are public for everyone. You can just contribute or just use it. Either way is fine, and copy it everywhere. These are the very strong opinions I formed doing this project. And the last thing, to us, the GPL made amazing assets available for use in this project. Some stuff we could never have done in a whole lifetime ourselves. The GNU toolchain, Linux kernel, Mandrake, the whole Mandrake distro with all the things in it. Box was used briefly, and BCC, the 16-bit C compiler. There was zero transaction cost on us to try this stuff or to use it in a redistributable form. No lawyers, delay, paperwork, liability, marketing bullshit, or greedy management fucks. I take it there are no greedy management fucks here tonight. Oh, there's one. Okay, I'm sorry. Sorry about that. GPL hardware is a growing trend too, not just in physical hardware, but also VHDL and Verilog models. And for many sectors, this value that's in IP assets that are available under GPL is going to overtake the similar IP that's available in the paid-for world. And many sectors of IP markets which want your money now will be eaten up. And I predict Office apps and operating systems are going to be the first where you can't make a buck selling them because the GPL ones are so good. Okay, that's it. Thanks very much.
Hello, I'm Milos Meriak, and okay. Hello, I'm Milos Meriak. I'm a freelancing software developer, and I'm focused on embedded systems, reverse engineering, and Linux kernel drivers and Windows kernel drivers. This includes low-level programming and with real time, so I get used to embedded systems. I have to strip down it a little bit because we want to keep some time for questions. issues for porting to Xbox. At the beginning, there were 6 possibilities. Open-free NetBSD, GNU Hurt, GNU Linux, proprietary operating systems. There are lots out there. Windows 96, 9X, and Windows NT 2000 XP. It's really possible to port Windows to Xbox, but we have not ported it. And why we haven't ported why we haven't ported Microsoft Windows? It's nothing personal against Microsoft Windows. It's because of high license fees. We are not allowed to patch binaries. This would be vital to get Windows up and running. And this is forbidden by the end-user license agreement of Microsoft products. It's mostly closed source. We have problems to find the points where we can change things. As we heard before, there are a few differences between a normal PC system and the Xbox. And there is a lack of open source Windows drivers. There are a few out there, but we have to program very much from scratch. In Linux, you have a bunch of applications, frameworks, which were very helpful for us. And basically, because it's open source, we can look down the sources, and we have to tweak a lot because of the differences. And we like the liberal GNU license model because it allows closed source kernel modules. We need this because NVIDIA only provides closed source kernel modules. It's well-known user-friendly if you're using KDE 3 or GNOME. And it already has a wide range of applications. It provides sophisticated development tools, which is really helpful for us. Basically, you can say we simply like it the most, so we start using Linux in the first step. And we want to boost the spread of Linux. The problem was, at the beginning, nothing could run on Xbox. So at the beginning, there was darkness. But Michael Stahl, with his exploits, found a security bug, and now we could say, let there be light. And now we provided a modified XBE, Xbox executable file, which proves that it's running by copying Linux Tux logo directly into frame buffer. So we have the possibility to show the world that we are running unsigned code without using the Xbox Development Kit. Because one of the license terms of Xbox Development Kit, even if you buy it regularly, this allows you to distribute your programs. You're allowed to program for yourself and later let it signed by Microsoft, but you're not allowed to distribute it. And everybody which is providing Xbox executables without going over Microsoft and let it sign, it's illegal. And we want to stay perfect legal, so Microsoft couldn't harm us. And basically I said it already. But we have the second possibility you already heard. We can replace the whole BIOS. But the problem remains that the NVIDIA chipset only has closed source drivers. We don't really know how it works, and it's not exactly the same as on PC-based architectures. This graphic chipsets is only available on Xbox. So the porting begins. We created a bootloader, basically grub. And to minimize size effects during the first steps, because we found a lot of traps, we started with clean ROM replacement. This was in first step a legal solution, because if you're using mod chips, they include patch Microsoft code. games is illegal because the mod chips contain Microsoft code. So we made this replacement in first step. We want to prevent 16-bit fiddling around with this bootloaders, so we skipped it and directly use the protected mode entry of the kernel. We see after the first step nothing because no video up. It's a real problem because we say, hey, we are running Linux, but nobody sees it, could see it. So we have no video output at all because we have no BIOS routines for screen setup, for chipset setup, and no VGA BIOS for providing installation routines, like on PC architectures. In our second step, we are using Andy Green's filter device driver as a simple debug console. It was mentioned before, the Xbox doesn't have any real I/O interfaces we could use, so we have to do this complicated approach. He said it before, bidirectional memory allows us to exchange data with the Xbox, and we connected it to a client computer and watch it on a terminal window. The device is basically polled by Linux kernel and the client computer, and so data can be changed successfully. This device allows us to see kernel messages, and so we can find the traps easily. Before that, we have to fiddle around with thinking what could be wrong and change here and change there, and it was really slow. And things speed up after we get kernel debug messages out. Basically, we hooked the kprintf routines, which are basically used for development and debug output. And we saw the first debug messages from kernel. It was really dirty. We fixed it at different places in kernel and unstable, and we could not post data to the Xbox because we only looked at the debug output messages. So we wrote a console driver, especially for the filter device, and the new driver allows us to see all the boot messages. And there we could see easily the messages and the Xbox hardware crashes, not Xbox kernel. It freezes and nothing gets executed if you access some PCI chipset registers, which you normally could access easily on PC architectures. And Linux could boot now cleanly. We created Linux distribution from scratch to fit in this 1 megabyte flash, and we basically used BusyBox, which is common in embedded systems, and it's basically a huge application where all Linux commands are statically linked in. You have one binary, and by calling it with a different name, you can get the other commands. And because it's in one binary, they can commonly use libc code, and the binary are very small then. To small it to make it smaller, we also use uclibc. It's a very lean libc. A libc is a set of routines you usually use to access low-level kernel routines. For example, if you want to put screen output there, or you want to read something from files, it builds an abstraction layer. On normal Linux systems, the normal libc is more than 3 or 4 megabytes, and it's definitely too much for us, so we used uclibc. And the result was a powerful embedded Linux system. And after bzipped the kernel and gzipped the initial RAM disk, it fits perfectly into 1 megabyte Xbox flash. Because of using the filter console driver with its bidirectional interface, it gave us access to the Linux console on Xbox, and we can get VI and interface config and things like that. Everything is working fine. We managed to get a closed source NVIDIA network drivers working, which was very cool for us because they are only manufactured by NVIDIA and there is no documentation about it. So this was a real help for us. We made our first release. Linux boots in a network enabled state. It was running a web server and a telnet daemon. And although there is no audio and video output and no input connectivity, keyboards, mouses, users have, using telnet, full control of their box. The first Xbox-based internet servers appear on internet. It was really cool to see Xbox internet servers provide some hacked Xbox games. The developers worldwide were now able to add more features. This filter device only was only 3 people worldwide had access to one. They built it by themselves, and it's really complicated. But now every developer with an Xbox can start developing. So we got very much developers from the whole world. This image provides us ability to mount NFS shells. So you can mount your PC, and because it's also Intel architecture, you can directly run applications by change routing to your NFS system on your PC, and you can start developing really quickly. As I said before, it includes a large number of Linux command tools, and the sound card were already enabled, and we had MP3 players out there. The embedded web server provides detailed information about the Xbox, which also helped us very much because it shows the Xbox serial numbers, and we could test if our algorithms work on every system. We get much data from people around the world. This is a picture of the embedded web server. You point simply your browser to the IP address of the Xbox, and you get this page. This is an excerpt of the system information it provided about CPU, about programs running, processes are up, memory consumption, and things like that, and the EEPROM content, which helped us for developing our algorithms. And a little greeting page. And within a few days, the count of developers grew enormously. The next steps of the team included, we have added a USB interface for mouse and keyboard support, FATX file system support, so you can access your Xbox directly from Linux for backup purposes and for doing whatever you want with your Xbox. We also added support for Xbox controller, so the Xbox controller could work as a mouse replacement. So nobody has to build connectors if he doesn't want it, because it's a non-standard USB connector. You have to solder your own. And this driver provides the possibility that somebody could easily try Linux by using his own controller as mouse replacement. The ROM image was becoming too tight. In 1 megabyte, we couldn't fit a whole X server and a complete embedded environment. So we created an Xbox executable bootloader for booting Linux from CD-RVs and DVDs. Because this happens after video RAM initialization, this enables us to access directly the video RAM. On recent hardware architectures, the video RAM is mapped linearly to the bus. So it's relatively easy to access it after its initialization. And after we have access to the initialized frame buffer console, it was possible to add frame buffer interface description. So Linux could understand the kind of frame buffer the Xbox was using, and it could use all the routines are already contained in the kernel to put boot messages out. And this was in the top part, and you see the boot messages after initial RAM disk has started up. And you see Telnet daemon is already started and web server is up. After that, things start speed up, and X server 4.x was running on Xbox, and the Xbox could be already used as Xbox terminal. It was really cool. For example, you could run applications on your home PC, and by using the Ethernet interface, it was possible, for example, to check your email on your home television. The applications are running on your PC, and by getting a remote X terminal, you could put them on a TV channel and could look your email every time you want. The first DivX films were running with sound, and they were running really smooth. Interesting links, basically our own URL, the Xbox Linux project, then the BusyBox. It helped us really much for our first steps. Then we use Tiny Login. It's a combination of PassVD, login, and authentication, set user comments. UClipsy, Linux from Scratch is a cool URL for learning something about compiling your own Linux system from sources. Boa was our web server. THTTP is already also a cool web server, which we are using now. And we also use the tiny Telnet daemon that fit perfectly in our 1 megabyte image. And so basically, everybody has the possibility to run a Linux application as he wants, and very much people around there start porting major distributions like Debian, SUSE, and Mandrake. And in the image you can see Xbox running a web browser, and Michael was writing his emails from Xbox and using OpenOffice directly on Xbox. I'll give to Michael. Thank you.
Yes, hello. Hello. Hello, I'm Lena Franz, and I'm speaking a little bit about Xbox hard disk key generation, if you get the picture. Yes, we are a little shortening the thing now, because we have only 10 minutes left. You see the first problem you see, and it spoke about it, we see public release, yes? And I usually publish my documents with public or unofficial releases. Yes, the first thing you have to learn is the hash systems. Hashes are very useful for creating a digital signature of a file. E.g., if you have a document which is very big, it is split up in 64 byte blocks. Each block is scripted with intermediate results, and the finished result is normally 160 byte thing, and you encrypt the thing, and this is the encryption. This is called a digital signature, and it's not more, but it's impossible to break a 160 bit encryption. This is okay. Yes. Okay, now we are coming to the Xbox hard disk key generation. As you see, we have decided not to publish the original key to the public as of license problems. So you see on the top, the EEPROM key is standing, and the key is coming down in two stages. The first stage is the key is expanded to 64 bytes and then hashed together with intermediate value coming out of the EEPROM. The EEPROM, this hash, now the EEPROM XOR 36, this value is it's the same now with this here, with this result. It's only not hashed with 36, but with 50, with 5C. And you see the flow diagram. I wanted to explain it, but we have a little less time now. Yes. After I did everything, and it took me about 2 days to think about the problem, I found a document in the internet on NIST which documented the HAMEC key generation process. This is a well-documented thing. It's used in every VLAN you are using here for encryption, and it's an official standard. And then I found the coolest thing ever. Kann man das mit Zoom ein bisschen? Also, okay. Here is standing. Conceptually, the intermediate. Oh, yeah. Okay. No? Ihr druckt. Oh, it's getting funny. Okay, the thing I found out is basically not a bug. The thing is basically a design implementation which was created to speed up the encryption. It's standing here. If you go to the next page, yeah. Okay, the laptop shoots down. Okay. It's no. I want to say this is no bug or no attack and basics. It's only optimization for the codec itself. This is very. I wanted to discuss about the legality problem of the whole thing, because in this case, the first time it appeared, and I found this bug everywhere, that every encryption code engine you get on the world has 2 stages. The first is the key setup and the key using. And after the key is set up and after the key has been set up, it is not the original key again and can't be calculated back. It's a unique key, which is which you need to operate, but this key in composite as compared to the original key is a legal key. You can use it without any problems, and and I think this is a very new finding out which should be discussed a long time later, and I wanted to discuss this on Crypt in internet. And the first thing I heard is that we are not discussing about legal attacks on any encryption code. So I think this is a thing which no US user, they should be involved, because every hacker or cryptographic which is living in US is a little bit afraid of some things. And yes, I'm good living in Austria. Okay, I'm giving notes.
Okay, we've got only 2 minutes left, so we're trying to show you what it looks like, and I hope it works. Okay, it was disconnected, so we got the screen. Oh.
Okay, we press B for boot Linux. Microsoft appears. And these are the boot messages you get.
Okay. We'll take a minute or 2 until it's finished booting. This is a Mandrake 9 distribution. It's the full Mandrake distribution. It's a standard installation which works without any problems on the Xbox. All Mandrake RPMs you can find on the internet can be installed onto the Xbox using the CD-ROM drive or the network connection, or directly through the internet through the update method. This is not the only image. We have a Debian-based distro, which is more hacker-like. It's marked unstable, and Mandrake is stable, and for people who want to really work with it. So if X Windows appears, I hope you will be able to see that the Xbox is actually it's actually real life, that it's stable, that you can use it as a computer. We have video up, we have a keyboard, we have a mouse. You can connect all standard USB devices that would work on a PC running Linux. And of course, you can also use it as a server. Hello, X Windows. Only 733 megahertz. Oh yeah.
I can use the mouse already.
Okay.
And the keyboard are basically connected by a simple wire device. You can buy extension cable of the Xbox controller, cut it in the middle, and simply solder it to your keyboard cable. And then you can use your keyboard and the USB hub to connect other devices.
Yeah, so you can use it as a desktop computer already, using our clean solutions or the original hacked MS BIOS. Oh.
Oh,
No, this is a standard installation. It is a guest and password guest.
okay.
It's not connected to the network, so don't try to hack it. Yeah, and since we got media players running on it, and yeah, and with media players, MPlayer, Freewo, all these applications work already. They work pretty well. We can say that the Xbox with the Linux is actually also ready for the living room. Oh, probably on the left there are the icons, huh? Ah. Okay, that's a problem with the beamer, but on a television it should work a bit better. Start a terminal. Okay, that was our 2 hours. I think we should stop now.